Welcome to Grablo. In this tutorial, we'll create a music spectrum visualizer using an 8x8 LED matrix. Ready to bring your music to life with lights? Let's get started. Create a new project and give it a name. First, we'll set up a dashboard. Click Add button in the left menu to create a new dashboard. Now let's add a push button to play music. Click the Add button and select a push button widget. Click Select Variable and create a new variable called Play. Select this variable from the list. Next, we'll create the logic for music playback and spectrum analysis. Add a new logic from the left menu. Add a new control and add a compare condition. Select the play variable, set the operator to equal with a value of true. Set the option to rising edge, which makes the condition trigger once when the button is pressed. Now add a play media action. Create a new player and select it. Grablo includes a sample audio file, so we'll use that for this example, though you can also upload your own audio files. Here's the key feature. Turn on audio analysis. This analyzes the music in real time, giving us frequency and amplitude data we can use for visualization. Click Add and select Frequency Amplitude as the data type. We'll start with 32 Hz for the lowest frequency. Audio files typically have left and right stereo channels. We'll use channel 0, which is the left channel for this example. Set the frequency to 32 and create a variable to store this amplitude data. Now let's add the next frequency at 64 Hz. Duplicate the previous setting and create a new variable for this frequency. Continue this process for 128, 256, 512, 1024, 2048, and 4096 Hz. These frequencies range from low bass to high treble sounds. This gives us amplitude data for 8 different frequencies total, each stored in its own variable. Since we need to analyze the music frequencies in real time and display them on the LED matrix simultaneously, we'll create the LED control as a separate logic. In Grablo, multiple logics run in parallel, enabling both music playback and LED visualization to happen at the same time. Pretty cool! Add a logic for LED matrix control and add a new control. And add a watch action condition. Select the music playback action and set the status to running. This ensures the LED matrix only updates while music is playing. Add an I/O device control action and create a new device. Search for and select NeoMatrix. This library controls WS281X LEDs in matrix form and works with Raspberry Pi. Set the GPIO pin to 10. NeoPixel LED matrices can use either PWM or SPI pins, but since PWM is being used for music playback, we'll use the SPI MOSI pin instead. We're using one 8x8 matrix, so leave the other settings as default. Select the device, and first add a clear command to turn off all LEDs. Now we'll set up the 8 columns of our LED matrix. Each column will represent one of our 8 different frequencies, ranging from low bass sounds to high treble. And the height of each column will show the amplitude of that particular frequency in real time. Let's start with the first column. Add an I/O device control action and select the LED matrix device. Set the command to draw line. For the line's start point, both x and y coordinates are 0. For the end point, the x coordinate is 0, and the y coordinate is determined by the amplitude value. To determine the Y endpoint, click the Block button next to Y endpoint to open the block editor. Drag a linear scale block from Math category and connect it to the return block. Add a variable read block, select the 32 Hz variable, and connect it to the input. Set the scale so that when amplitude goes from -48 to -6 decibels, the Y-coordinate goes from 0 to 7. Think of -48 decibels as very quiet sound and -6 decibels as loud sound. This range covers most music levels. This maps that frequency's amplitude to LED column height. Set the color type to HSV and the H value to 0 for red. HSV's H value ranges from 0 to 360, where 0 is red. And as you increase the value, colors transition through orange, yellow, green, blue, purple, and back to red. Duplicate this for the second column. Change the x-coordinates to 1. Use the 64 Hz variable and set H to 30 for orange. Continue this pattern for all 8 columns, using different frequencies and colors for each. Finally, add a show command to display the pattern on the matrix. For better responsiveness, edit the logic and set the execution cycle to 1 millisecond. This updates the display 1,000 times per second. Perfect! Our project is now complete. Let's quickly review what we've built. We created a dashboard with a play button and 2 separate logics, one for music playback and frequency analysis, and another for LED matrix visualization. Before running the project we just built, ensure your hardware is connected, as shown in this table. The NeoPixel LED matrix connects to Raspberry Pi GPIO10 with an external 5 volts DC power supply of at least 3 amperes. The Raspberry Pi cannot provide enough current for the LED matrix, so external power is essential. Once connected, we're ready to test. Connect to the controller and hit the Run button to start our project. Press the play button to begin music playback. Look at that. Our Spectrum Visualizer is working beautifully, responding to the music in real time. Wait a minute though, it looks like the LED matrix is displaying upside down. Let's correct this problem. Stop the controller, go to Settings, and edit the matrix device. Set first pixel position to top right and rotation direction to 180 degrees. Run it again, and now you have a properly oriented Spectrum Visualizer that creates beautiful patterns matching your music. Congratulations! You've successfully built your Grablo project. Ready to explore more? Check the links for tutorials and support. Thanks for watching and enjoy creating with Grablo.